Let's start part two of 1.6. In part two, I'll discuss with you equations with rational exponents. Then we will discuss equations quadratic in form, and the last one, absolute value equations. Let's start with the first one, which is equation with rational exponents. If someone gives me an equation like this, let me first change the color. For example, x to the power of 2 third equal, let's say, 64. How to solve such a equation and which kind of equation we call these types of equation. I put just a very simple form for you. X to the power of 2 thirds equals 64. Look at to the exponent or to the power of x. The power of x is a rational number. It's a fraction, correct? If the power of your variable is a rational number, we call these types of equations equations with rational exponent. Now, how to solve? Solving these equations are really easy if we remember these rules from our previous class. First, we had a power rule. If I have a to the power of m over n, to change rational exponent to radical form, you may remember that you change any number with rational exponent, you can rewrite it as a radical form. What you do, a to the power of m over n means you have to open a radical. Your denominator, let me use again color, n, which is your denominator. This one is always your index, the index of your radical. It means write the n here, the nth root of, then move your number under the radical a, and this m becomes exponent under the radical. It means it will be the nth root of a to the power of what? A to the power of n. Or sometimes we change this notation, we do this way. This one can be written as a n root of a, then you can put the power all the way outside to the power of m like this. Sometimes it's easy to use this one. Sometimes it's easy to use this one. I'll tell you how. For example, if I have, let's say, 64 to the power of 2 thirds, correct? If I rewrite this one and simplify this number, I can write as a cube root of 64 to the power of 2. If I want to simplify here, I have to first square 64, whatever that number is, then take the cube root, and that will be my answer. You see, when you are squaring 64, it gives you a bigger number that you may not know what is the cube root. You have to use calculator. But if I write this problem like this, 64 to the power of 2 thirds equals the cube root of 64, then all to the power of 2. It's much easier to deal this way because I know the cube root of 64 is 4. Then 4 is square, which gives me what? 16. Which way you use it, you have two options. I hope you remember it back. It was one of the rules of radicals with rational exponents, correct? And rational exponents. Okay, one rule to remember. The second rule that you have to remember, and it's the easy rule from fractions, that if I have a fraction in the form of m over n, to change this fraction to 1, the value of this fraction to 1, I can multiply this fraction with its reciprocal, correct? I can multiply it with n over m. And if I do this, my answer is always 1. My answer is always 1 because n cancels out with m cancels out with m, and my answer is 1. Correct? One more rule that here we have to remember. Do you remember if you have a to the power of m all to the power of n, the power rule of exponents? To simplify this, you can write a to the power of, you multiply these two numbers, right? Two exponents, m times n. That's it. If you remember these three rules, and they're really easy rules, you can solve a lot of equations with rational exponents. I'm not telling you all of them because some of them you need in future, you will see in chapter 6 or 7 that you will use logarithms to solve them. But here, the easy ones, if you remember this three rule, you can solve any equation that's our equation with rational exponent. Let me do a few examples for you. Example number 1. Let me copy this example from your book. 3x to the power of 3/4 minus 6 equals 0. If I solve these one step by step, you want to isolate your variable with its exponent in one side and move all the numbers to the other side. Okay, because in every equation that you solve, that's your goal, to have your variable in one side and all other terms on the other side, right? Having this in mind, then what is my first step? I will add 6 to the both sides, correct? 6 cancels out with 6, then 3x to the power of 3/4 equals 6. Second step, I have to get rid of this 3. Then what I do, I'll divide both sides by 3. These 2 cancels out. X to the power of 3/4 equals 6 over 3 gives you 2. Now, I want to have x alone. And I explained to you already that if you have a fraction in the form of m over n, if you multiply it with its reciprocal, it becomes 1, right? I want to get rid of this 3/4. What is the reciprocal of 3/4? The reciprocal of 3/4 is 4/3, correct? And it gives me 1. Then what I do, I'll raise both sides to the power of 4/3. That means I'll do this. X to the power of 3/4 all to the power of 4/3 equals 2 to the power of 4/3. Based on the rules of the exponent that I explained to you, if you have a to the power of m all to the power of n, it's equals a to the power of m times n. I can multiply these two fractions. 3 cancels out with 3, 4 cancels out with 4. What left? Only x to the power of 1, right? X to the power of 1. It means x equals 2 to the power of 4/3. Last step that I want to discuss here, what you can do here, just raise 2 to the power of 4/3. How? I explained to you already. A to the power of m over n, you want to write it as a radical, in radical form. It will be the n root of a all to the power of m here, or maybe m here under the radical. Then x equals, open a radical, 3 comes here as the index, 2. If I put 2 here, look, it's easy to think. I don't have the cube root of 2. But if I put the power here, this time here, it's much easier. Then x equals the cube root of 2 to the power of 4. It means 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is what? 16. Then x equals the cube root of what? 16. And instead of 16, you can write x equals the cube root of 8 times 2. Because 8 has a cube root, right? The cube root of 8 is 2. You can see it here. The cube root of 8 is 2. Correct? Then x equals, the cube root of 8 is 2. 2 outside. Then 2 radical cube root of what? 2. Final answer. Correct? Oh, if you use a calculator, maybe you end up with 2.52. But in this class, I will not ask you to find exactly how much is the cube root of uh, 16. If you can simplify this much for me, that we usually do this, we are not going to change it to a decimal number, that will be the right answer. Correct? Let me do another example for you. Example number 2. X to the power of 2/3 minus 3/4 equals negative 1/2. Again, first thing to do, if you are good with the fractions, move your fraction to this side. If you are not good with the fractions, how to deal? What is the common denominator? The common denominator is 4, right? Multiply everything by 4. In your book, immediately what they did, they start moving this fraction from this side to this side, and they solved this problem involving with the fraction. Yes, I like it. I don't want to do extra steps, but I'll show you both ways. Some of you, I know, maybe you have problem with fraction. To get rid of this fraction, you have to multiply everything by what? By 4. Then you end up with 4x to the power of 2/3 minus, here 4 cancels out with 4, you left with 3, equals 4 divided by 2 gives you 2. 2 times negative 1 gives you negative 2. No fraction, correct? Now, add 3 to both sides. Then 4x to the power of 2/3 equals positive 3, negative 2 gives you 1. Now, divide both sides by 4. Then x to the power of 2/3 equals 1/4. Now this is the time to use your exponent rule. The reciprocal of 2/3 is 3 halves, right? Then I'll raise both sides to the power of 3 halves. X to the power of 2/3, all to the power of 3 halves equals 1/4 to the power of 3 halves, correct? 2 cancels out with 2, 3 with 3, then x equals 1/4 to the power of 3 halves. You can write it as a radical. It means the square root of 4. You see, this time I'm putting the 3 outside because it's much easier this way, because I know what is the square root of 4, correct? Then x equals square root of 4 is 2 to the power of 3, which gives you what? 8. Final answer, correct? Oh, I'm sorry, it's 1/4. 1/4. Here will be 1 to the power of 2 to the power of 3, and your answer. I totally forgot about that one. Here your answer is 1/8. But plus minus because you have a square root. The other way, if you want to deal with fraction, if you are good dealing with fractions, you don't need to multiply everything by 4. You had x to the power of 2/3 minus 3/4 equals negative 1/2. I will add 3/4 to both sides. Here you go, 3/4. These two cancels out. X to the power of 2/3 equals, you need here common denominator, then here times 2 times 2. Negative 2 plus 3 gives you 1 over 4. From here on, it's the same. If you are good with the fraction, no need to remove the fraction. But if you are not good how to add, how to subtract fractions, you can always remove the denominator by multiplying all the terms by LCM. Then you can simplify your question, correct? There are, I'm sure, a lot of problems in the homework of this section. Of course, I assigned few of them for you. If it's not enough, you can take some more problems, solve it, but usually I assign few problems from each section. Now, the other part of this lecture is equations that are quadratic in form. Equations that are quadratic in form. This is the topic of what? Discussion. There are some equations that they are not quadratic. You cannot call them quadratic. They are not quadratic. They are not second degree, but they are quadratic in form. Correct? For example, if I write for you x to the power of 4 minus 8x squared minus 9 equals 0, this equation, I can call it quadratic in form. Why? Why I can call it quadratic in form? Look at the exponent of your first term and look at the exponent of your second term. If I divide 4, which is the exponent of the first term, by 2, it gives me the exponent of the second term, which is x squared. Am I right? Why we call it quadratic in form? Because you see, if I write the general form here for you, ax squared plus bx plus c equals 0. That was your quadratic. The difference be between the exponents of the first term and second term. If you divide the exponent of first term by 2, it gives you immediately the exponent of the second term. That's why we call these equations quadratic in form. They are not quadratic. When you solve, you may end up in this problem with 4 solutions, correct? Which quadratic usually has 2 solutions, but here you will end up with 4 solutions. But still, we call them quadratic in form. Calling these equations quadratic in form makes it easy to solve. How? Correct? How? One of the methods, the easiest methods that I want to discuss here with you, and it's also in your book, using substitution method. The substitution method. If you use the substitution method, it means you're dealing with quadratic equation. It's really, really easy to solve them. Look, what you do, let me put the example back here. For example, you had x to the power of 4 minus 8x squared minus 9 equals 0. What you do, the lowest exponent involved in your equation is x squared. Name your x square u. Another alphabet, another variable, but we usually use u. It's not a standard. It's not something that I can ask you, oh no, always make it u. No, you can name it m, you can name it n, correct? Whatever you want to, it's just substitution. But usually we use u, make it u, name it u. Okay, now question. If x squared is u, what is x to the power of 4? What should I name x to the power of 4? Or let me write in black. What should I name x to the power of 4? In terms of u, x to the power, I'll show you in this example only, x to the power of 4, I can write it as x squared all square. Am I right? Because x squared all square gives you x to the power of 4. And I already named x squared what? I already named x squared u. Then x to the power of 4 means u squared. You can name it u squared because x squared is u. You see, if you substitute here, it gives you u squared. That's it. If you can do this, use substitution. Solving this equation is really easy. What? How? I'll name my x to the power of 4 u squared minus 8. What is x squared? My x squared, I named it u, minus 8u minus 9 equals 0. Do you see it become a quadratic? And all of you, you can solve this quadratic equation. We discussed 4 different methods to solve a quadratic equation. The easy one is factoring. If you can factor, it's really easy to solve. Let's try if we can factor. open two parentheses, equal to 0. Of course, u here and u here, correct? Two numbers to multiply gives you negative 9. To add gives you negative 8. Of course, negative 9 times 1. Because negative 9 times 1 gives you negative 9. And if you add negative 9 with 1, it gives you negative 8. Then my factors are u minus 9 and u plus what? 1. Now, using the 0 property, u minus 9 equals 0. It means u is equal what? 9. Also, u plus 1 equals 0. It means u is equal negative 1. But remember, is this the solution of the equation u equal 9 and u equals negative 1? Should I say, oh, this is the solution, I'm done? No. Look at your original problem here. In your original given problem, you don't have u, you have x, correct? Then you need to do one more step. Substitute back the value of u, because let me rewrite here, your u is x squared. Substitute back the value of u and your answer and solve it. Okay, I have u equals 9. What is u? U is x squared. It means I can write x squared equal 9. Now, solving this equation, square root of x squared equals plus minus square root of 9, which means x equals plus minus what? 3. Two solutions here. Also, I have u equals negative 1. It means x squared equals negative 1. Again, taking the square root from both sides, square root of x squared equals plus minus the square root of negative 1. It means x equals plus minus, what is the square root of 1? Remember, we named the square root of negative 1 I. Then x equals plus minus what? I. 4 solutions for your equation. X equal 3, x equal negative 3, x equal positive I, x equal negative I. 4 solutions for this equation, because the equation was originally degree 4, but it was quadratic in form. Correct? One more example. 5 x to the power of 2/3 plus 11 x to the power of 1/3 plus 2 equals 0. Again, how I should know that here and here, if I divide the first term by 2, it gives me the second term. Look at here. Denominators are the same. It's between 2/3 and 1/3. Denominators are the same. If you divide 2 by 2, the numerator by 2, it gives you 1. That's numerator, correct? It means the difference is what? 2 again. Now, what I do, I'll name my x to the power of 1/3 u, and I'll name x to the power of 2/3 u squared. That's it. This is the main part that you have to focus, how to name them. The lowest exponent, the lower exponent, u, the one that's multiplied by 2, that's u squared, correct? Rewrite the problem. Then you can write 5, 5 u squared plus 11 u plus 2 equal 0. Can we factor? Of course, here 5u and u. And what are the factors of 2? The factors of 2 is 2 and 1. I can write 2 here, 1 here. Both numbers should be positive because here I have positive, positive. But sometimes you may put 2 here, 1 here. This is not the correct factor. You have to check. How you check? You multiply these two numbers, which gives you 10u. And you multiply the nr, which is 1 times u gives you u, and you add. If it gives you the middle term, which is 11u, your factor is correct. If it doesn't give you the middle term, you have to replace the numbers and play around, correct? This method, we call it trial and check, correct? It's in your book. Okay, after I factor this, now it's not difficult. Set each parenthesis equal to 0. 5u plus 1 equals 0. Subtract 1 from both sides. Then 5u equals negative 1. Divide both sides by 5. U is equal negative 1/5. Second parenthesis, u plus 2 equals 0. It means u equal what? 2. Last step, bring back the value of u. What is u? Here, you see on the right side, u is x to the power of 1/3. Then here you can write x to the power of 1/3 equals negative 1/5. Oh, exponential equation. You already learned how to deal with this problem, correct? To simplify this, I'm raising both sides to which power? To the reciprocal of 1/3. Reciprocal of 1/3 is 3, right? Equals negative 1/5 to the power of 3. Here, 3 cancels out with 3. X equals negative 1 to the power of 3 is 3, and 25 to the power, not 25, 5 to the power of 3 gives you 125. One answer. Here, instead of you can write x to the power of 1/3 equals 2. Again, raise both sides to the power of 3, x to the power of 1/3, all to the power of 3 equals 2 to the power of 3. These two cancels out, x equal 8. Second answer. This equation has only two answers. That's a negative 2. Negative 2, sorry. I do some mistakes, negative 8, not positive 8. This was solving equations in quadratic and form. Let me show you one more example, a little bit different one, not difficult one. That's also quadratic in form. Then I will stop the lecture, and then in the next video, I'll do for you the absolute value equations, correct? Let's do this example. Example 3 or 4, I don't know which one, 3, I think. X squared minus 5 all to the power of 2 plus 3 parentheses x squared minus 5 minus 10 outside equals 0. Is this quadratic in form? Look, your first parentheses to the power of 2. Your second parentheses, which is the same as the first parentheses, but the power is 1. Then, easy to solve. I'll name x squared minus 5. What? U. correct? If I name this one u, this one immediately becomes what? U squared. Then my equation will be this form: u squared plus 3u minus 10 equals 0. And easily I can solve this equation. It's the easiest one, right? Can we factor to parentheses u and u? Possible factors of 10 to gives you 3. 10 times 1, 2 times 5, only two options, right? But because 10 is negative, it should be negative 1 times 10, and negative 2 times 5 gives you negative 10. Why the lower number negative 2? Because I already explained it in factoring for you. You need positive 3, right? Then your factors are u plus 5 and u minus 2 equal to 0. So set each one equal to 0. U plus 5 equal to 0. It means u equals negative 5. The other one, u minus 2 equals 0. It means u is equal to. But what was u? U was x squared, what? Plus 5, something? Minus 5. X squared minus 5. Replace back or substitute back the value of u in each answer, right? X squared minus 5 equals negative 5. Solve it. Add 5 to both sides. X squared equals 0. It means x is equal 0. Here, x squared minus 5 equals 2. Add 5 to both sides. X squared equals 7. It means x equals plus minus the square root of what? 7 for answer. This was two other parts of 1.6, which we are discussed the equation that's exponential in form and uh, uh, equations with rational exponents and equations quadratic in form. Correct? I'll stop the lecture here and I'll put the absolute value equations in the third part of 1.6. Correct? See you all in the third part of 1.6.